Okay guys, as promised, I told you that I was going to tape and record what we are doing today in class. So what we are doing today in class is we are talking about derivatives and tangent lines. Now, just so you guys know, this is the general form of how we are going to find a slope for a tangent line. And just to kind of remember, if I have a slope and a point, remember the slope is m and the point that we are given is x1, y1. So before we even begin on trying to find slopes from equations, what I want to kind of do is remember how to create a tangent line. So we are given a point and we are given a slope. What I'm going to do is I'm going to use that y minus y1 equals m times x minus x1 equation to create the tangent line. I'm simply just going to plug in everything I have for all my variables. So I'm going to do y minus 2 equals 3 times x minus 1. And if I wanted to, I could go through and I could simplify this, and I could call this y minus 2 equals 3x minus 3, and I could take it one step further, and I could say y equals 3x minus 1. And therefore, I've created a tangent line given a slope and a point. Okay? Let's go ahead and try this again over here. What I'm going to do is I'm given a point. This is x1, this is y1, this is my slope. I'm simply going to plug it into that above equation that I see. Now be careful, I'm subtracting a negative, okay? Let's not pull a baby freshman mistake. And I'm going to change that, and I have x minus 1 here. And then it ends up being y plus 1 equals negative 3x plus 3, and I could go ahead and simplify this and make this y equals negative 3x plus 2. Okay? So, what we are doing today is we are going to be given a curve, okay, and we are going to be creating tangent lines from a single point. So as you can see, I just drew some curve, and we are going to be finding tangent lines, and what we are going to be looking at is the slope of a tangent line. Okay, so this is really what we're looking for. What is its rise? What is its run? And how do we find that? So before we even begin, it says, well, what does slope look like? Well, in algebra, it looked like this equation, y2 minus y1 all over x2 minus x1. Before we could really define it down to these simplistic terms, we used limits to define slope. Okay? And what we're going to do and how we are going to define it using a limit is going to look a little something like this. So, we are going to say that the slope is equal to the function of x with a little bit of change of h minus the function of x all over x plus h minus x. Now, you might be thinking, I don't really understand what this means, okay? Think of this value right here as y2. Think of this value right here as y1. So this is the x2 value, this is the x1 value. And as I go through and simplify it, in simplistic terms, slope really looks like this. F of x plus h minus f of x. As you guys can see, this is just a change of y all over, well, x minus x cancels, and for some reason, all I'm left with is an h. And this is where the limits come into play. Okay? So, what we are going to do is we are going to take, and I'm sorry that I had to flip the page here, we are going to take this function, f of x equals x squared, and we are going to try and apply that rule that I just had. So I'm just going to kind of quickly remember what that rule is over here. We're going to say it's f of x plus h minus f of x all over h. And you're thinking, this doesn't really look like a limit. Well, it will. What we're going to do is, I keep telling you this, you can't divide by 0, you can't divide by 0, but we are going to make this h so small that it does become 0. So this is what it's going to look like. It's going to look like the limit as h approaches 0 of f of x plus h minus f of x all over Okay? And if I am remembering my rules correctly, what I'm going to do is I'm going to replace this entire function. Well, f of x is being defined as x squared. So I'm going to do the limit as h approaches 0, and everywhere I see an x here, it's telling me to plug in x plus h. So I can do that. I can do x plus h. That function is being squared, so I'm going to square that, minus the original function, which is just x squared, and it's all over h. And right now, this doesn't really mean a whole lot to us. So I'm going to maybe try and FOIL this out or multiply it and see. And using our 3, 4, and 1, 2 skills, we realize that this is x squared plus 2xh plus h squared minus x squared, because that's what that is, all over h. And as we can see, I have a positive x squared here, I have a negative x squared, and are we allowed to cancel? Absolutely. So that's what we're going to do next. We're going to say the limit as h approaches 0 is these are going to cancel, and I'm just going to be left with 2xh plus h squared all over h. And as we can see, all three terms, this 2xh, this h squared, and this h all have an h in common. So I'm going to go ahead and simplify those by a factor of h. Now I'm going to make it the limit as h approaches 0 is 2x plus h. And right now we don't quite understand what we're doing, so I'm going to go ahead and plug in 0 for h. As I do that, I'm going to find that I get 2x plus 0. Therefore, my slope is equal to 2x here. Okay? So, what we have just found is that if we found any point on this function of x squared, like for instance, if I wanted to know the slope as I draw out this function, okay, just real quickly here, and I'm going to draw as much as I can. This is a little bit impromptu here, but here's what that quadratic function looks like, right? Like, there it is. And let's say I wanted to find the slope when x is equal to 2. So I'm talking about this right here. All I would need to do is I'd have to plug in 2 here. So m would be equal to 2 times 2, which means the slope is 4. So at this given point, I know the slope is equal to 4 of that tangent line that I just created. Okay? So, what I want to do now is see if we can do the same process, maybe with a harder function. Okay? So, we are going to take the function f of x equals x squared minus 4x minus 2. And I'm going to use that same rule. I'm going to plug in x plus h here. I'm going to plug in x plus h here. And then I'm going to subtract the entire original function. So I want to know, and it's going to be kind of lengthy. So the limit as h approaches 0 of x plus h squared minus 4 times x plus h minus 2. So realize this is all of f of x plus h minus the entire original function, x squared minus 4x minus 2, all over h. Okay, so here, that numerator is going to look like this. So again, the limit as h approaches 0, because we have not done that yet, we haven't actually applied the limit, it's going to be x squared plus 2xh plus h squared minus 4x minus 4h minus 2. And then I'm going to go ahead and distribute that negative throughout that entire f of x function. So minus x squared plus 4x plus 2 all over h. Now, I am hoping some stuff cancels here because that looks like a pretty intense equation. And lo and behold, I have an x squared, I have a negative x squared, those will kind of cancel. Here I also happen to have a negative 4x and a positive 4x, those are going to cancel, and I have a negative 2 and a positive 2. So if I go through and rewrite it, I have the limit as h approaches 0 is 2xh plus h squared minus 4h all over h. And what you're going to see is, again, for some reason, all of these terms have an h in common. So the limit as h approaches 0 will again simplify to 2x plus h minus 4. Now, as h approaches 0, well, there's a 0 here. So what that means is my slope equation is actually, if I plug in 0 for h, is just equal to 2x minus 4. Okay? And I understand if you guys are going to need me to clarify this a little bit more when I get back, but understand what we're doing is this is a slope equation for any point that I want to plug in from this function. Okay? So using this slope equation, I have two questions over off to the side here. Okay? And I'll rewrite it just so that we kind of have it again. I have, let's just remember, m equals 2x minus 4. It says, at what point on the graph does the slope equal 6? Well, it's telling me the slope is equal to 6. So over here, that means I actually want to replace m with 6 because I'm solving for the x value. So 6 is equal to 2x minus 4. You're just going to go through. You're just going to solve. So 10 is equal to 2x. Therefore, 5 equals x. But realize it says at what point. The point is, well, they're telling me the x value is 5. So what I can do is I can actually go back to that equation, which was equal to x squared minus 4x minus 2, and I can plug in 5. So I get 5 squared minus 4 times 5 minus 2, and I get 25 minus 20 minus 2. So do that math, 25 minus 20 is 5, minus 2 is 3. So the point and the answer to this question would be 5, 3. Okay? And then it says, what is the equation of the line tangent? So tangent, I'm looking for a y equals mx plus b equation to f of x that passes through the point negative 2, 10. So again, we're going to use that same f of x equals x squared minus 4x minus 2 equation. Okay? But realize, if I am trying to create this equation, they have to give me two things. They have to give me a point, and I have to know the slope. Okay? According to this problem, I absolutely know the point. The point is given. The slope, however, I'm going to use that slope equation that I found. The slope was equal to 2x minus 4. Now you might be thinking, well, how am I supposed to find m? But remember, when they give you the point, they give you the x value. So the x value I'm going to use here is going to be negative 2. So m is going to be equal to 2 times negative 2 minus 4. So I get negative 4 minus 4. Therefore, the slope of this tangent line for the given function that I just did is negative 8. Now let's go back to that y minus y1 equals m times x minus x1 equation, and I'm simply just going to plug in everything they've given me. y1 happens to be 10, m is negative 8, and your x1, be careful, we're going to have a double negative, which will make that a positive 2. So y minus 10 is equal to negative 8x minus 16. Therefore, my tangent line is equal to negative 8x. If I move that 10 over, it becomes minus 6. All right, ladies and gentlemen, I know we might have a few questions, but go ahead and try that homework, and I will do my best to answer your questions when I return.